Hi, this is Bill again, continuing the BilroCAD tutorial series. We're going to try and get a little bit further on this platform. Going to a plan view, issue the mirror command to mirror that footplate. See, we're in ortho mode, so that's done. And mirror that again. Whoops, I didn't hit enter. You have to hit enter down here. Sometimes people forget that. And hit enter again to repeat the last command. There are the two legs that we're liking. And if I mirror him around there, you can see I made a mess of that one. So we just move that one there down a bit to the dot Y of there. Let's have a look, see what it looks like. We checked that that was 2500 from distance from there down to there. Now that is 2500, but I've just suddenly realized, oh gosh, and this is great in a way because it's going to show you how to get away from something that you've done wrong. If you put footplate on a concrete floor, the likelihood is the concrete floor is not going to be very even. So to give everybody a half a chance, usually what you do is you put that footplate 30 millimeters off the floor. So if I go in for move, click them all, and I've got ortho on, so I just key in direct distance entry 30. Now, how do I slice all those off? You go for a little slice command, S-L-I-C-E, pick all your objects, and cut them off, pick that one, pick, and that just slices them off. Slice command. Very nice. Now that is going to have a piece of concrete, or what they call grout, underneath it. Now see, I'm got my X and Y running that way. I want to be drawing on the floor. So if I choose the world coordinates, see how it slips it round like that. So now what I'm going to do is draw a rectangle. And just put the rectangle on the bottom of there. And now I'm going to offset that rectangle by 30 millimeters. Offset 30. For reasons which will show up in a minute. And now I'm going to move that downwards by 30. So if I hold down Shift and hit my middle mouse button, you can see what's happening there. You've got a rectangle up there and a rectangle down there. So that's going to represent the nice sloping surface of the grout. So we need to use the loft command. Pick that one and pick that one and hit enter and job done. That little, oops, didn't like me pressing escape. Okay, issue the command again. Can happen. Enter and enter again. I didn't hit enter twice. So that, if we copy that one everywhere else but loose, ideally to be nice fast drafts people, we should have issued that command when we drew the foot in the first place. I blame the weather. It's not very good here in New Zealand. Okay, so we got their thing. We can look at it from the front. We can look at it from the left. And 3/4 view. And we've drawn the floor in. Now, to draw a kick plate in that floor, which is usually made out of 100mm wide material by 6mm, or 5mm, sorry, we can reuse this here. I should have made another copy of this because it would be handy to have. If I copy that over there and look from there, we can see that it looks like that. If I explode that, that is no longer a solid. It's broken up into all its bits. So we can make use of that. We can erase that bit there, and we can erase that bit there. And there's a little tiny little bit there left. That there is now what they call, with the properties bar, properties, it's called a region. Okay, and that's when you explode things like that, they end up being a region, which is fine. It means that we can just, we can't offset that. If we try to issue the offset command by 5, it says no, you can't do that. It doesn't want to know. So we have to explode that one, and now it's from individual lines. So we need to PE, polyline edit, pick a line. It says, do you want to turn it into one? Yes. Hit enter on yes, and J for join. Join all those lines together. Thank you, and hit enter, and now it's all one piece. Now we want to offset that by 5mm, and it will do it. There we are, like that. So there's our polyline there, and another polyline there. If I extrude both of those by 100, there they are. But that's one slab of butter, that's the other. If I shade it, you can see that. So that's no use to you. So you want to have subtract command, subtract from this one, that one there. So now when you shade it in, it's looking a bit like a kick plate. Of course we'll have to cut bits out where you walk up through the stairs up there. That's no big deal. So we move this one, move this one, plonk him on the top of the floor. There he is there. Okay. Now, handrails or stair rails? Or stairs first? Well, probably the stairs come first, because if you can't build the stairs, you can't do anything, can you? Now we've got 2500 to get a whole lot of steps up. And when you're building a stairway, you should always consult your standards that you're supposed to be following. In the case of New Zealand, they seem to follow Australian standards, and there's fairly strict rules about what you can have in the way of a stairway. So we'll first start by issuing the cal command, ccal. By the way, I have a list routine that does all this for me, and I'll demonstrate it at some stage. Cal 2500, and we'll divide it by 200. And you get the answer 12.5. So it's obviously going to be around about cal 2500 divided by 13. So it looks like 13 spaces and 192.3 mils apart. I know it sounds a bit pedantic talking about 0.3 of a mil and 0.07692, but if you want it super duper accurate, you probably worry about the 0.3, but none of the others is probably worth worrying about. So that's the bits that it's going to go up at, and And so now we need a footplate. Go to CAD library, CAD drawing mechanical, plates, standard drawings, common parts, stair parts. So we've got a footplate. What have we got in the way of a footplate? We've got a stair footplate. We've got this, that's a tread, 600 by 270. Well, that's around about the right size of the tread. So we just drag that into our drawing, and it's a detailed drawing of that. So that's obviously not the right one, because it's got the word dim after it. So nowhere in there have I got, I think this is the same sort of thing, this is 609, this is, yeah, it's the same sort of thing. That's the development of them. So, see the 270 and 270 roughly is the thing. So we'll just draw it from scratch quickly. I thought I had one in there. So quickly we're doing 25 up, 270 that way, and instead of 25 we go up by 20. There's our tread, and we've offset that by 5. Draw a line from there to there, and a line from there to there. So normally, if you're a fussy person, you'd have that nicely radius as 5 there and a 10 there. I think my school of thought is I don't put radiuses on this sort of thing because what do they tell you? Nothing. And what good are they? Nothing. They make absolutely no sense. They take up time, they take up memory, and they make the drawings look pretty crap anyway. The only thing is that if you have a section, it makes them just look a little bit more believable. So we've got a polyline here and a thing there. We can, to make that into an extrusion, we can issue the REG command, turning it into a region. It's made into a region, so that now we can extrude that one by 600 millimeters. So there it is, sitting out there on lonesome. If we move it to the edge of the floor here somewhere, just anywhere will do, and look at it from the side. Now remember where we said we worked it out, 2,500 divided by 13 was 192.3. So if I copy this and I go at well, it's 270 minus 30, must be about 250. We'll make it a 250 going, at 250 going horizontally by 192.3, enter, and enter again. That means we finished copying it. So that there has got an overhang from there of 20 mils. Should really be 25. So we'll move that back just ever so slightly by 5 mils that way, and just measure it again just to make sure. 25 mils. So that's a nice comfortable sort of, you're not bringing your foot down and hitting that thing there. Of course there are rules as to whether or not this times that equals a good number. And we can issue the cal command. Just check that out. 192.3 times 245, and it comes to 47,113. I think from memory the good number is somewhere around about 46,500 or something or other maximum, but it's immaterial for this because this will never be built. Your one will be obeying the standards that you have to follow.